Implementing MPLS on top of an existing IP4 network. Let's jump in. Here are the opt-out questions for this video. Take a moment, read these 3 questions, and if you know the answers and are comfortable with each of the topics, hey, I'll see you in the next video. For everybody else, we're going to take a look at how to both implement and verify that MPLS is working. Let's begin. I'd like you to consider something with me just for a moment. Let's think about all the people on the earth right now who, at this very moment, might be preparing and starting to learn MPLS and MPLS applications, such as Layer 3 VPNs. Now, out of that group, whatever that number is, how many of those people studying MPLS are going to become really, really good at it? And the answer is about 5 to 10% of people who study some topic are going to rise to the top of their field. So, for example, it may be this person, and maybe that person, or very likely it could be you. And it's no accident how these individuals, including yourself, are going to get very, very competent at a technology. And that, my friend, is through hands-on practice. And that's why in this course, if you'll be willing, I'd like to set you up for success by sharing with you how you can set up your own lab. And then as we go through the videos together in this course, you can pause me as often as you like and practice right alongside of me as we implement MPLS and the MPLS applications that make it so desirable. So here's the ingredients list I'd like you to put together as we create your own private lab environment that you can practice on. First of all, we're going to start with GNS3. Now I'm using 0.8.6. And if you're using a more current version like version 1.0 or version 1.x, it'll have the similar functionality that you need to practice the MPLS. The second thing you're going to need if you're using GNS3 is some type of an iOS operating system image that supports the features of MPLS. And the iOS image I'm using in GNS3 for this class is a 7200 series image with the Advanced IP Services feature set. And you don't have to use that exact model of hardware. And you don't have to use this exact flavor of iOS as long as it supports the protocols we're going to use in class, primarily MPLS. You should be fine. You can also be running iOS 12.x or 15.x. That also is not going to have any significant impact on what we're going to be doing in this course. So if you do have an iOS image and you're not sure whether or not it supports MPLS, there's a couple ways to figure that out. Number one, we could just try to implement MPLS on it. And if the commands don't take, that's a good indicator that it doesn't have those features. Or secondly, you could use the feature navigator up at Cisco, put your version of iOS in there, and then simply verify whether or not the features of MPLS exist in that version of the operating system that you're using. The host operating system that I'm going to be running GNS3 on for this series is Windows. It's running version 8.1 of Windows. However, if you're on a different platform, for example Macintosh or Linux running GNS3, you should be able to create the same functionality from an emulation perspective. And with Windows, if you're on version 7, for example, of Windows, that should also provide you the same functionality from a GNS3 perspective. So pretty much our bases are covered. Macintosh, Linux, Windows, various flavors of Windows, and then various versions of iOS, 12.x or 15.x, as long as it has the MPLS feature set, which the Advanced IP Services does. Now what I would love to do in this video is we're going to take a look at how to put the pieces together in GNS3. If you want to dig deeper into GNS3 and learn additional things, for example, how do we integrate things like VirtualBox with GNS3? How do we create virtual hosts in GNS3? I would recommend go checking out my GNS3 series. There's a whole course dedicated just to that. And in the context of our MPLS course, we're going to simply use GNS3 as a tool, an emulation tool, to provide our test environment. And that same thought holds true for things like IPv4 subnetting, IPv6, or using Wireshark. I've got separate courses all available for you as a member at CBT Nuggets, so you can dig deeper into any of those topics just by watching those courses. So here's the play-by-play for this topology. I've got this diagram for you in the Nugget Lab file. So if you want to download that and take a look at it and have it available to reference, all we need to do right now is work with R1 through R5, these 5 routers right here. So using this topology, let me walk you through right now how to create that topology in GNS3. So when I opened up GNS3, it's asking me, okay, do you want to create a new project? I'm going to say absolutely yes. We'll call this MPLS-demo. And we really don't need to worry about clicking any of these 3 checkboxes. If you do, it won't hurt anything, but you don't need to. And then we'll simply click on OK. So here in GNS3, we have a blank canvas to play with, and we're going to go ahead and simply drag out 5 routers to represent routers 1, 2, 3, 4, and 5. So to do that, I'm going to click on the router icon, And the fact that these two are highlighted represents that I've already identified the iOS image to use for either of those platforms. Now, for those of you who have set up and worked with GNS3 before, you very likely already identified the iOS image to use. If you haven't, I would strongly recommend you pause this, go check out the GNS3 series, and walk through the first few videos, which will step-by-step show you how to prepare and get the back-end ready of GNS3, including identifying the iOS image that you want to use. And then once you do that, you'll have the availability to drag these router platforms over here to create your topology. Now, as I mentioned, I'm going to be using 7200s for our time together in this course. So I'm going to go ahead and click on the C7200. And then with my mouse clicked, I'm going to drag it over to the free space. And there's R1. And I'm going to simply repeat that process. Click on the router on the left, drag it out for R2, another one for R3, another one for R4, and another one for R5. Now, as we configure and bring up these routers, if your CPU goes through the roof, just pegs at 100% and stays there, obviously that's not going to be a viable solution. So if you do have excessively high CPU for a long duration, when running GNS3, you definitely want to check out those first few videos in the GNS3 series, which will walk you through how to set up and control the idle PC value, which can help prevent your CPU from going up to 100% and sticking there. Now, for the connectivity between these 5 routers, we're going to be using gigabit. And if you'll notice in the topology, between R1 and R2, I'm using gig 10. And from R2 to R3, I'm using gig 20. And 3 to 4, gig 30 on both sides. And then from R4 to 5, I'm using gig 40 on both sides, meaning on both routers. Now, there are several different ways of adding those modules to these routers. For example, slot 1 and slot 2 and slot 3. And what I'd like to do is show you one method of adding those that if you follow, you can get the same results that I'm having. However, you are welcome to do it in any fashion that you want to. So what I'm electing to do is I'm going to go into each router manually and specifically tell that router, hey, in slot 2 you have a gigabit Ethernet and so forth. So let's start at R1. So we're going to double click on R1. From this pop-up window, we'll simply click on R1. And then the third tab over, we have the slots tab. And for R1, I want to put a gigabit Ethernet module in slot 1. So I'll go down to slot 1 from the drop down here. And from here, I'm going to select the PAGE, which is a gigabit Ethernet interface that will now be in slot 1. And we'll click on OK. Next, we'll go to R2. And on R2, let me slide this over just a little bit. And if we want to follow this topology, on R2, we're going to want a gigabit Ethernet in slot 1. And we're also going to want it in slot 2 for the interfaces going to R1 and R3 respectively. So no problem. We'll simply select R2, go to that third tab, which is called slots. And we'll go down to slot 1 and say I want to have gigabit Ethernet there, and slot 2, I want gigabit Ethernet there. So if you're following along with me, you can pause my video, do this step by step along with me to build this topology of these 5 routers. And then we'll click on OK. And we'll repeat that process for R3. And with R3, we want gigabit Ethernet for the second slot and the third slot. So we'll click on R3, go to the third tab over called slots, and add one for slot 2. And one for slot 3. And then click OK. And going on to R4, we'll double click on the R4 router. In R4, we want gigabit Ethernet in slots 3 and 4 to match the topology. So we'll go ahead and add that by selecting R4, clicking on the slots tab, going to slot 3, the drop-down menu, selecting gigabit Ethernet, and the same for slot 4. And the last router in our domain here is R5. So we'll go to R5, double click on him. Select R5 from the list, go to slots, and we need 1 gigabit Ethernet in slot 4. So with the drop down from slot 4, we select gigabit Ethernet, click OK, and now we've got those interfaces. Now we can simply link them together. So on the left hand side, we can go ahead and close this little router window, and if we want to see our connector tool, it's this little icon right here. So we can click on that, and then on R1, we simply click, it'll say, what do you want to connect from? We'll say gig 10, and then we'll go over to R2 and click, and we'll select gig 10 there as well. And then from R2, we want to go from gig 2 to gig 2. And then from R3, gig 3 to gig 3. And from R4, from gig 4 to gig 4. And now we have our connections in place. Now the other thing we want to do is we want to go back to that connector tool and turn it off so that it knows we don't want to add any more connections. And the other thing we might want to do is click on the labeler so it can go ahead and show the interface labels. And there's our interface labels. And then last but not least, we'd want to go ahead and turn these on. Now we could right click and start each of these independently. That would work. Or we could click on this arrow icon right here, which would go ahead and launch all of the routers. So we wouldn't have to do each one manually. Once they're up and running, we could use this icon right here to go ahead and connect to the console port of each of those routers. And in your studies, if you do want to pause here and go over to the GNS3 series and maybe spend a half hour there or 45 minutes there to get your comfort level up with GNS3, the more you know about GNS3, the better you'll be able to make it work. So if you're brand new to GNS3, again, the GNS3 course is also available to you as part of your membership at CBT Nugget, so please take advantage of that. And then what we're going to do is we're going to configure the loopback and gigabit interfaces. So for each of the routers, for example, on R1, we're going to use 1.1.1.1/32 for a loopback interface. And on R5, 5.5.5.5/32. And the same thing for R2, R3, and R4 using their router numbers respectively. Also on these gigabit Ethernet links here, we're going to use the last octet the same as the router. So R1 will end in .1, R2 will end in .2, R4 will end in .4, R3 will end in .3, and so forth. And then we're going to enable OSPF on all the gigabit interfaces here and on the loopback interfaces. So when we're done, we should have reachability between R1's loopback 0 and R5's loopback. Now I've got great news for you regarding all of this configuration. In the Nugget Lab files, I've got the base configuration for R1, R2, R3, R4, and R5. So if you wanted to go into configuration mode and copy paste them in, if you're using these interfaces, all that work will be done for you. Now if your topology is slightly different and you have different interfaces, you can still take the configuration files that I provided for you in the Nugget Lab files for this video and simply edit them to match the interfaces that you're using. So for example, here's the configuration for R1, and it has the loopback 0 and the gigabit 10 and everything else that I have in my base topology. So I just provided these in the Nugget Lab file so it could save you some time with the base configuration of IP routing and so forth. And then once you build that, we can then go ahead and add the MPLS together, and that's what I'd like to do with you right now, is add on top of our topology the MPLS. One of the very first things that you and I had to do is just verify that our base infrastructure with basic routing is working for IP version 4. So let's do this. Let's do a trace route, sourcing it from R1's loopback 0 of 1.1.1.1 all the way to R5's loopback 0 of 5.5.5.5. And if that works, that would help reinforce that our basic IPv4 routing is working. And that looks great. So our first hop was R2, and then R3, and then R4, and then R5 got it. That's fabulous. Now what we're going to do is on top of our existing working IPv4 network, we're going to implement or add into the mix the MPLS components. Now to enable MPLS, we're going to do two basic things. In global config, we're going to use the command MPLS space IP in global config. And that says, okay, I'm willing to do MPLS. And the second thing we're going to do is going to go into interface configuration mode for the interfaces that we want to enable MPLS to actually work on and enable it there as well. So for example, on R1, we'd go to gig 10 and say MPLS space IP. And you know what's interesting? This is one of the commands that's very rare in that it's the same exact syntax in global config to enable it globally as it is in interface configuration mode. And we'd follow that process on R2, R3, R4, and R5 on their respective interfaces. Gig 2 between R2 and R3, Gig 3 between R3 and R4, and so forth. What I'd also like to do is let's also set up the range of labels that each of the local routers can generate. So for R2, we'll give it a range of 200 through 299. For R3, we'll give it a range of 300 through 399, and so forth. So that in our lab environment together, the one that you're building and the one you're watching me do with you, we'll have an absolute knowledge regarding who sourced some label based on the range that we're allocating for each router. So since we're at R1, let's go ahead into configuration mode, and we'll set up first of all the range of what labels R1's allowed to use. And we're simply going to say, Mr. R1, your MPLS label range is going to be 100 to 199, and that's it. So if he has more than 100 labels, 100 to 199, that he needs to generate, he's going to be in trouble because he's going to run out of label space. Next, let's enable MPLS globally with the global config command of MPLS space IP. And then last but certainly not least, we need to enable MPLS IP on the specific interfaces that we want to actually use MPLS label switching on. So in the case of R1, if we look at the topology, that's going to be interface gig 1/0. So we go into that interface and use the command MPLS IP. And then I've saved the configuration to startup config. WR is simply a shortcut for the command copy space run space start, which is a shortcut for copy running config startup config. Now that that's done, let's move over to R2 and give him the same treatment. We can go a little faster on this one. We'll enable MPLS IP in global config, and we'll enable MPLS IP on R2's gig 1/0 interface and on its gig 2/0 interface. Now you notice in the background, it also did something for us. Once we enabled MPLS on the interface, it actually built an LDP neighborship. LDP, the Label Distribution Protocol. LDP is the language of love, or the protocol for label distribution, that allows R1 to tell R2 about its labels, and to allow R2 to tell R1 about R2's local labels and their associations. And we'll have a whole separate nugget where we'll dive deeper into label distribution protocol. Next, let's move on to R3, and we'll do the same thing. We'll set the label range for 300 through 399, we'll enable MPLS IP globally, and then we'll enable MPLS IP on gig 2/0 and gig 3/0 on R3. And we'll also notice here that R3 has formed an LDP neighborship with R2. So those guys are happy exchanging their local label information with each other. We'll continue to R4 and do the exact same treatment. We'll set up a range of labels for R4 from 400 to 499. We'll enable MPLS IP globally, and then enable MPLS IP on interfaces gig 3.0 and on gig 4.0. Now my intention is for, as we do this together, that you're pausing me periodically and doing these commands on your own lab environment, so you can practice with these commands. Also, I've included these commands that I'm doing right now as far as adding the MPLS. I've included that as part of the Nugget Lab files for this video. You could also copy and paste the MPLS commands, but I would recommend the first several times to go ahead and do it by hand to help get that muscle memory and the hands-on practice as far as implementing MPLS. All right, last but not least, we have one more router. That's router 5. So we'll go ahead into configuration mode. We'll set his label range from 500 through 599, enable MPLS IP globally, and then we only have one interface, gig 4/0, that we're going to enable MPLS on, because the customer-facing interfaces off to the right, those fast Ethernet interfaces, we are not going to have our LSP, our label switching path, be part of the actual customer networks. The LSPs are all going to be inside of our routing domain. And we have a good indicator here that our neighbor R4, from a label distribution protocol LDP perspective, looks pretty healthy. Our neighborship is up, and we're exchanging labels with R4 as well. So let's have some fun with this. Let's pick one single route out of all the routes available. Let's pick 5.5.5.5, and let's ask a few of the routers, hey, what is your local label that you chose to associate with the network 5555? We can also ask each of the routers, hey, by the way, if you were going to make a forwarding decision, what label would you inject as you forward it to your next hop? And because I already looked at the topology, here's the labels that R2, R3, and R4 have chosen for 5555. R2 chose the label of 203, and R3 chose the label of 303, and R4 chose the label of 403, and R1 chose the label of 103. And because R5 is directly connected, he said, you know what, I'm not going to have to generate a label for that. I'm directly connected. It uses a reserved label number for that, which we'll talk about here in a little bit. So if these are all the local labels, what we would expect to see is that R1, if he was forwarding a packet based on MPLS, the label switching path would go like this. And as R1 forwards the packet, he would inject label 203. And when R2 sees that label, it would immediately swap it out and forward the packet to R3 with the label of 303. Who would then see that label, swap it with label 403 and send it to the peer R4, who would then forward it down to R5. So let's go over to R1 and ask that question in order of each of the routers. And the syntax is show MPLS LDP bindings, then the network and mask that you're trying to identify. And R1 is saying my local label that I assign for network 5555 is 103. Now, because I brought each of these routers up systematically and I constrained their label space, it just is a coincidence that they're all ending in a 3. In a production environment where you're not constraining label space, it would be very difficult to predict on all your routes exactly which labels are going to be assigned to which routes. R1's also saying that, hey, I learned from my good buddy R2, whose label switch router ID is 2.2.2.2, that R2's label is 203. And then to confirm what this router would do based on forwarding a packet to 5.5.5.5, we can say, please show us your MPLS forwarding table for 5555. And what this says, it says the outgoing label I'm going to impose is going to be 203. That's the label that R2 said he's using for that network. There's the actual network we're talking about. There's the outgoing interface, and that happens to be the IP address of the next hop. Even though we are not making forwarding decisions based on that IP address, it already knows exactly who that neighbor is. And all this information is cached. So if for some reason we had a packet that was sent into R1 and it had a local label of 103, it wouldn't even bother looking at the layer 3 information. It would simply swap out the label for 203 and then forward it on to R2. Let's ask the other routers the same exact question. What is your local binding for 5.5.5.5, and what is your forwarding table for that same network? So here on R2, it says its local label is 203. We already knew that. And my forwarding table for that network says I should impose label 303 for that network. And my exit interface, my egress interface, would be gig 20, which is right there. And the next hop would be good old Mr. R3. And again, it's going to do that without even bother looking at the layer 3 information. If it receives a packet with MPLS label 203, it'll immediately swap that with 303 and then forward it up the interface to R3. Let's ask those same two questions of R3. So on R3, we'll do the show MPLS LDP bindings regarding 5.5.5.5, and then we'll do a show MPLS forwarding table for that same network address. So R3 says, yeah, the local label is 303. If I receive a packet in and it has that 303 label, I will immediately swap out that label with 403, and I will go ahead and forward it out gig 3/0, which is right here, to the next hop, which is R4. You'll also notice that R3 had a couple of choices too. He's got two neighbors, R2 is a neighbor and R4 is a neighbor, and they were both advertising that they had local labels for 5.5.5.5. In the final analysis, the way that R3 is going to make a decision as far as building the forwarding table, should I use 203 or 403, the answer is going to be based on the IP routing table at the end of the day. So when we take a look at LDP in more detail, we'll confirm and walk through the steps of verifying that it's building the MPLS forwarding table as a result of what it believes about the IPv4 routing table. Now the last router we need to ask is router 4, and so we'll do those same two commands there. Show MPLS LDP bindings regarding 5.5.5.5, and please show us the MPLS forwarding table for 5.5.5.5. So here R4 is saying my local label is 403 regarding that prefix. And I had two neighbors advertising that they had local labels for that route. I had R3, who was telling me that R3's label is 303. And I had R5 telling me that the label is called implicit null. Now, implicit null is a reserved label. Now, in reality, the implicit null is the label number 3. So 0 through 15, those numbers specifically are all reserved labels. And label 3, which is the implicit null, is the label that a router will assign to a network if it is directly connected. So because R5 is directly connected to its loopback 0, it's advertising this label 3, or the implicit null, up to R4, and that's why that's here. So from R4's perspective, if it receives a labeled packet of 403, what it's going to do, it's going to go ahead and pop off that label, effectively remove that MPLS layer 2.5 altogether, and then simply forward outbound on gig 4/0 right here to the next hop, which is R5. Now, why would R4 totally end the MPLS path for network 5555? Really, R4 is like a good buddy. For example, let's say that you and I are in business together and we've divvied up the responsibilities. And one of my responsibilities that I have is to sweep the floor every single day at the end of business. That's part of our agreed responsibilities. Well, let's say I've had a really long day, I'm just totally shot, and you come up and say, hey, you know what? I'll take care of that for you. I know you got a lot going on. I'll sweep the floor for you today. Well, that's what R4 is effectively doing for R5. Because R4 receives something called the implicit null label from R5, which means to R4, oh my goodness, R5 is directly connected. And here's what R4 thinks. R4 thinks, you know what? Because R5 is directly connected to that destination network, it really would be an extra waste of time for R5 to have to process the MPLS header just to realize it's directly connected, and then go ahead and process the layer 3 header anyway so it could forward the packet based on IP to its final destination. So what R4 is doing is something called a PHP, the penultimate hop pop. It's popping off that label before it hits the final router. So for example, in the Olympics, they talk about the penultimate event. It's the one before the final event. Well, in the case of this packet being forwarded to R5, R4 is that PHP router. And as a result, it's going to remove the label altogether and simply do IPv4 forwarding to the final destination because R5 is directly connected to that IPv4 network. There are options to keep that label on there and make R5 pull it off, but the default behavior is penultimate hop popping. And that's why it says here, if I receive a packet with a label of 403, I'm going to pop that label off. I'm not doing a swap. I'm simply popping off the label, and then I'm simply going to forward it. And if we were going to do the same commands again on R5, just to validate R5, it would show us that its local label is the implicit null, which is the reserved label 3. So here on R5, it's showing us that the local label for 5555, because he's directly connected, is the implicit null. It's also showing us that R4 is advertising his local label, because that's what LDP does by default. We advertise labels to all of our neighbors, upstream and downstream. And then from an MPLS forwarding perspective, R5 says there is no outgoing label. And because R5 is directly connected, that's the end of the IPv4 path as well. So you want to see something really, really cool? Let's go all the way back to R1. And on R1, let's do that same trace route we did earlier before we had MPLS. But now that we have MPLS, Cisco iOS trace route will include the MPLS labels in the path to that destination. So we'll do our trace route to 5.5.5.5, source it from our loopback 0. Now the actual path, R2, R3, R4, R5, that hasn't changed, but the manner by which these packets were forwarded has changed. We actually use the LSP, the label switching path. So the packet on the way to R2 had the label of 203 imposed on it by R1. R2, when it received that, swapped it out, put on label 303, and sent it over to R3. R3, when it received label 303, swapped out 303 and put 403, sent it over to R4, and because R4 had received the implicit null from R5, R4 removed the MPLS header and forwarded the packet naked, or if you will, natively, IPv4-wise, over to R5. And that's why this last leg of our journey doesn't show an MPLS label associated with it. Also, because a ping didn't mess with the precedence bits, the experimental bits have not been set. So the 3 experimental bits are 000 by default for any MPLS devices that might be paying attention to those bits. So here's what I'd like you to do. On each of these routers, once you've built this label switching path between R1 and R5, I'd like you to save the configs on each of your routers. So I'm going to go through each of the routers and save the configs. And then I'm going to open up GNS3 right here and make sure I click on this Save Project icon right here. I want to save that because we want to be able to come back to it and continue building our MPLS infrastructure. So again, the good news is that the base configs for the basic IPv4 and routing protocols are all available in the Nugget Lab files for R1 through R5, and the commands that we just did together to add on the MPLS, I've also included that for you for your reference in the Nugget Lab files for this video. So the key element is practice, practice, practice. And if you need to go over this video a few times and pause it as you go through to build it, I would strongly recommend you take the time to do it now. Now the reason is this: the more you practice with MPLS and the basics, the more comfortable you'll be as we start adding on the additional features to deploy full-blown MPLS applications like Layer 3 VPNs. So practice, practice, practice. Your mission, should you choose to accept, is simple. Please practice everything that you've seen us do together in this video. And also I want you to go back to the beginning of this video and check out the opt-out questions just to make sure that you're now comfortable with those concepts. I have had a blast in this video with you, and I'm glad that you joined me for it. I hope this has been informative for you, and I'd like to thank you for viewing.